Hello, everyone. Very excited to see so many different names from almost all around the planet. And for sure, some of the people will actually get the link after the webinar and watch it a little more offline. My name is Felix Reichenbach. I've been with MongoDB for a couple of years, and I'll be guiding you through this presentation together with my colleague, Joy. And Joy, maybe a few words from your side.
Yeah, hi guys. I'm really newer, not many years, 4 months at MongoDB, but as an industry solutions consultant. And I hope you enjoy what we've prepared for you today. We've put a lot of love. It's good stuff. So thanks for having me, Felix.
Perfect. Then let's have a look at the agenda, what we have prepared for you. And Joy, I think I need your help because there's too much lag.
Okay, let's go for it together.
Perfect. So I'll actually start with a quick introduction on what we have built at MongoDB and what's new. And then Joy is going to guide you through or give you an overview about our end-to-end data integration. I'll then explain a little bit about the new feature time series collections. And then Joy is really going down into the technical details of how to configure Kafka connectors to make it all work. And we will then finish it off with two little demos, one about the data streaming part itself, and I'll show a little bit about MongoDB Charts and how easy it is to create great visualizations on top of the collected data. And at the end, we will have plenty of time to answer any sort of questions, and you will also get asked to provide your details if you want to reach out to us afterwards of the webinar. So I think let's get started. And you all likely, or most of you probably know that MongoDB, the database technology, the MongoDB binaries built with the document model has become incredibly popular. And since a couple of years, in 2016, I think we launched our MongoDB Atlas cloud service. And just as MongoDB, the binary itself, it's actually just a fully managed MongoDB service. And it's therefore built on top of the document model, and the document model is the superset of all the other data sets. So it makes it really easy to store all sorts of different data inside of MongoDB as well. And one feature we're going to take a closer look today is the time series collections, which will allow you to store and process time series data more efficiently in MongoDB, just like you do it with other time series databases as well. Cool thing is the MongoDB query language, MQL, also was extended to accommodate the needs of people dealing with time series data. And I'm going to give you an overview about what new features have been added, and there will be more features added in the future. MongoDB Atlas, the cloud service, has a few other options which are not available in the MongoDB binary, the on-prem version. One of it is Lucene full text search indexing, so Atlas Search. A really cool feature. Wherever you build a UI and you want some type ahead fuzzy matching functionality, you can literally use that through the MongoDB query language without having to duplicate data into another search engine. Straight on top of MongoDB, directly natively integrated. We do have a mobile database. We're going to talk about this in another webinar, probably early next year. And then we're really going to focus on real-time analytics or near real-time analytics, including the data lake capabilities, offloading hot or previously hot data into cheaper storage like S3 buckets or Azure Blob Stores. And in the next webinar, we will show you how you can then quickly and efficiently analyze hot and cold data together through the federated API and with the BI, SQL, and Tableau connectors available. The whole MongoDB cloud is built on top of AWS, Azure, and GCP. And you can span a MongoDB cluster across these three cloud providers. It's becoming more and more popular. People start on one of these three, and then they likely want to use some of the functionalities, features, differentiations on the other cloud providers. And we allow you to bring data across the different clouds easily with a few clicks or an API call. We also have leading edge security functionality down to field level, and we can even query encrypted data, encrypted fields, which is really cool. And feel free to Google it or reach out if you have further questions towards that. So we can handle your most confidential data within MongoDB Atlas as well. And with that, I hand it over to you, Joy.
Right. So I guess let's just dig into what we're calling our framework for end-to-end data integration. So now what we've done is we've created a 4-step framework. All of the 4 steps start with the letter C, so you know it's like legit. But let's see what we have. So the very first step is our connect step. So this is basically about how you establish a communication interface between your machines or your devices and software. So essentially, you want to be able to see the data that your devices are producing, and at the same time, you want to send data to your devices to trigger different processes on your production line. That leads into the second step, which we call collect. Now, this is really where a lot of our focus today is going to be, because we're going to show you basically how we collect production data from devices using MQTT, and we stream that into our Atlas time series collections. Now, we're going to follow this up a little bit, like Felix has mentioned, with the compute step. Now, this is basically where we discuss data visualization and how that powers base analytics on your MongoDB data. The fourth step we've included is our create step. And this is a step where we show you how we leverage the data that we've collected in other steps and the analytics that we're doing to then build powerful applications that can improve your production processes. Now, like I said, we're really going to be focusing our effort on the first two steps and give you sort of like a sneak peek, a teaser, if you will, of our data visualization capabilities. But we'll hope that you join us in the next webinar, September 26th. So you see that at the end, all the details you need to go through the other half of this framework. Now, I don't want any ambiguity on what we talk about when we refer to the factory. So this is our factory. I want you to have a clear picture of what that means. So essentially, it's a small scale model factory that we've acquired. It has different stations, but it basically mimics common aspects of a production line. So we have inventory, we have a vacuum gripper, we get environmental data, that sort of thing. So if you just turn your attention to a highlighted video on your feed, you're going to be able to see the factory. So I just want to check that everyone's has the highlighted vid. Thanks. All right. So basically it's on, it's working, and this is where we're going to be getting our data from today. So from nothing, we're going to be creating a new Atlas time series collection and streaming data into there from the factory in real time. So now if we look at the different stations, we can try to identify controllers, but this, this is just the physical aspect of it. Let's really dig into what the factory is really doing. So let's go back to me. Right, so we see that our factory in real time as we speak is generating various types of time series data. So at regular time intervals, it gives us data about humidity, it gives us data about brightness, about temperature, it gives us alerts when there's any movement on the factory. We see readings on air pressure, air quality, and really a huge variety of metrics. But what this means is that we're ending up with a large volume of data that we need to store and optimize, store as efficiently and reliably as possible. But before we go into like how we store that data, I want us to have a clear overview of what our solution architecture looks like. So we're going to start from the factory itself. So that overview you've seen, I've just overlaid that to help you understand that we have 6 controllers on our factory, one of which, the green one, functions as sort of like a master broker, a local broker for the factory. And what this means is that messages that are transferred from different devices are all routed through this device using the MQTT protocol. So what we've done is we've attached this to a remote MQTT broker, building an MQTT bridge. Now, this remote broker just allows you to have access to all the messages on board the factory, but literally from any IP address in the world, so remote. Then we extend this functionality for streaming using the very popular data event streaming platform, Kafka. We set up a couple of connectors, and we use that to get data into MongoDB Cloud. Now, as he has explained, there's a whole suite of products embedded in MongoDB Cloud, or Atlas as we call it. You have Atlas clusters, the actual collections, or have application services, where we're then able to build application backends that are tied to the data that we have in Atlas. And above all, we have MongoDB Charts, relatively new, but then we're able to generate compelling data visualization so we can run analytics on the data we stream through Kafka. So in another webinar, we'll probably cover a bit of more about the apps we've built and such. But for today, let's zoom in just a little bit more into the specific architecture that is relevant for today's session. So like I said, Model Factory, we've built an MQTT bridge, but the stars of the show are really going to be our source connector and sink connectors that are deployed in our Kafka environment. And you see that we're trying to get these specifically into MongoDB time series atlas collections. Now, we're stressing this, or we're laying emphasis on the time series collections because they've been so optimized for time series data, and it's probably newer than a lot of people would expect with the compression rates. But I'm going to hand you over to Felix so he can really run you through all of the benefits and all the good stuff that lies underneath the hood in Atlas time series collections. Felix, over to you.
Yes, thank you, Joy. And if you could move to the next slide, please. Perfect. So for people who have worked with MongoDB for a while, may have come across the bucketing pattern, because MongoDB has actually been quite popular to process time series data as well. And what people did to optimize processing and storage cost and efficiency, people created buckets of different time series records. So like a document with an array, which then contains all the time series events over, let's say, a minute or an hour, depending on your specific use case. That allowed to have less, let's say, if we do every second a time series entry, we reduce, for example, index sizes by a factor of 60, because we literally have one document containing 60 entries. And that was already an incredible boost with regards to optimization. And now it required a little more sophisticated query, kind of an upsert query, which then added or inserted a new document. And that was quite cumbersome, and there was a lot of room for improvement. So we figured, why not take off that burden of the developers and make time series collections a native part of MongoDB. So time series collections are not just a feature of MongoDB Atlas, they're literally part of the MongoDB binary. And so you can use that functionality wherever you want and can run MongoDB itself. So we've abstracted that bucketing pattern. And now you can literally just insert records like you see it on the bottom right into MongoDB collections. And in the background, a similar approach like the bucketing pattern will be applied automatically for you. But bucketing is just a little part of the whole story. So if we go on to the next slide, we will actually see that we've added a whole bunch of other improvements to MongoDB time series collections, or MongoDB in general. So the easy integration in the top left corner, which simplifies working with time series data, inserting time series data into MongoDB time series collections. And we then added clustered indexes on the right, which dramatically optimize performance of these types of data. Range queries, etc., are dramatically accelerated. We've further expanded the Mongo query language to be able to process with time series data, the bottom right, window functions, gap filling functions, and a bunch of other things. And further improvement, which is available in MongoDB Atlas, is basically automated data lifecycle, which is built on top of our data lake capability, leveraging block storage like Azure Blob Storage or AWS S3 to offload cold data automatically, depending on a filter you can configure into that object store, by further providing you a federated API to query the hot and the cold data together. This is also going to be part of the next webinar. I think a very powerful feature, and it makes working with time series data over large time periods super efficient and super easy. So we've further added other functionalities. And so the time series collections were introduced in version 5.0, released last year. 6.0 was just released about 2 weeks ago, I think. And over the time, we've added, as I mentioned, window functions, temporal expressions, additional secondary indexes, added support for sharding. Time series data usually comes in large volumes, so you want to make sure that you can actually leverage the horizontal scalability of MongoDB. And we've added one more feature, which is column compression. It's quite impressive. And if we look at the next slide, we'll actually see how that affects storage utilization. So on the left bar, we see 107 megabytes. That's raw BSON data. So the raw data you ingest into a MongoDB collection. By using columnar compression, we can actually reduce that amount of data down to 6 megabytes, which is already quite impressive. And then, as you know, and we've had that for a while since we introduced Wired Tiger storage engine, we have basically block or page level compression, and we can further reduce the amount of data down to 2.2 megabytes. So it's not too bold to say that we can easily compress time series data way above 90% in most of the use cases. So storage footprint is incredibly low. Leveraging the clustered indexes, etc., will make your queries even faster. And then you can apply all the different aggregation expressions on top of it to make sure you have basically deep insights into your time series data. Cool. Over to you, Joy. Next part.
Right. So we're getting into really the meat of things, right? I guess the moment we've all been waiting for is showing you our process for data streaming. So we're going to look into the connectors, really down to the nitty-gritty of the configuration that we've set up. So as expected, you're going to need to set up your development environment. And in our development environment, you can decide to deploy this locally on a Confluent cloud. You can deploy it on a serverless backend. There's really a variety of ways to go with this. The only thing to know is that you're probably going to need some of the building blocks that we talk about here. And we have used components that are certified by Confluent to make sure that they're always available and updated. So they may come in the form of packages, containers, or NPM packages, depending on your deployment needs. So let's get into it. The first package that you're probably going to need is your Zookeeper. Now, this stores the metadata for all your Kafka clusters. It works as sort of like a centralized system for your Kafka brokers. Speaking of Kafka brokers, you're going to need a Kafka broker. So your Kafka broker essentially works really similar to an MQTT broker. It acts as an information hub for you to subscribe to or publish from different topics across your Kafka environment. Next, you're going to need Kafka Connect. Now, this works as the directory or the runtime environment for all your connectors. So we'll be deploying our connectors inside of Kafka Connect, and then that's how we choose which connectors are active, which are deactivated, and so forth. Finally, you're probably going to need your schema registry. Now, while this is not absolutely necessary, I think it works well in our case for us to be able to define JSON as the common data format for all of the topics that our Kafka brokers are going to read from or write to. Now, as we mentioned, the stars of our show today are source connector and our sink connector. Basically, what you need to know, you probably already know, is that your source connector defines the origin of data that you're going to stream through Kafka. Your sink connector defines the destination of the data that you've collected through Kafka. So let's start with the source. So basics, our source allows us to subscribe to specific MQTT topics, allows our Kafka broker. In this case, you can have several topics, like we are reading different types of sensor data, we're getting data from inventory, and maybe we want to map all of that to the same topic. So your source connector allows your Kafka broker to subscribe to a specific topic. And then it maps those MQTT topics to a chosen Kafka topic. So you decide what you want the name of your Kafka topic to be. You'll see what we use in ours, and maybe you can take inspiration from that. Finally, we're able to configure message value conversions. So if you decide that the format that you receive data in is different than what you want to store it in, you make those adjustments in your source connector configurations. So now we're actually going to look into the actual configuration. So this is really an exact replica of the connector that we're going to be streaming from today. But I want to highlight some points that you probably want to look out for when you're configuring your own connector. Now, the first of them is the connector class. This is actually like, what connector is this? In this case, we see that it's io.confluent. All of that means is that it's a connector created by Confluent, and it's created as an MQTT source connector. So it is used in a situation where the source of your data is coming as MQTT messages. Now, this is ideal because the class of your connector determines what configurator properties are available for it. Now, one of the properties of this MQTT source connector is that you can give it access to your MQTT remote broker. So the broker we defined in the previous stage in our solution architecture, you're just able to plug it in here, make sure that it has remote access to your broker, and then you define a broker client. Best practice would be to use a new client for every single, should I say, process that you want to run using your remote broker. Another thing you're able to do with this is define the topics. As expected, Kafka works on a topic basis. So you map specific MQTT topics to a Kafka topic. Now we have chosen, you can map multiple topics, multiple MQTT topics to one Kafka topic, but you really can't do vice versa. So watch out for this. In our case, we've mapped 3 of them to one Kafka topic that we're calling sensor surveillance camera. Now I want you to just take note of that name because we'll be seeing it again in our sink connector. Now, the rest of the configuration options are really just generic defaults that you have. that come with this connector. So whether you add them or you define them specifically, it doesn't really matter. Now let's go into our Sink connector. Things get really exciting because, I mean, this one is the MongoDB one, so it's good stuff. But here we're able to specify the destination to which data is sent from Kafka. Now, in our case, we've made it very clear that we want to send our data because it's time series to a MongoDB Atlas time series collection. So we specify that to our connector, and I'll show you how. Now, not only does this send your data to the Kafka connector, it also allows you to automatically create the time series collection. So if the collection doesn't already exist, it will create it for you in the database that you specify. As expected, it can configure your document field value conversions. This means that if you are storing data in Kafka in JSON, or then you decide that you want it in BSON for MongoDB Atlas, you're able to do that. So whatever your desired format, as long as it's compatible with your database, you're going to be just fine. So again, this is the actual configuration that we're going to be working with today and streaming data from. And we're going to highlight the important parts of this. So like I said, your connector class determines the configurator properties that you have. In this case, it is a MongoDB, our own proprietary connector, and it is our Kafka Sink connector. So this will be available online. We'll leave all the links so you can just go, pick this up and edit it to your desired results. Next, we're going to be mapping our topic. So I asked us to take note of the Kafka topic because we're going to need it again in the Sink connector. So what this does is that it tells Kafka that this is the destination for the connector that has a source with the same Kafka topic. So you always want to make sure, sometimes you're typing and you've missed it along the way, but you also want to make sure that your Kafka topics across source and Sink are the same. That is what connects them. You're also able to grant your Sink connector access to your MongoDB Atlas cluster. So you give all the relevant user details, user password. You specify a database that you want to create your time series collection in, and then you just assign a name to your collection. Like I said, this automatically creates your collection, even if it doesn't already exist in Atlas. Then you're able to set up the time series fields. Now, these three lines are really key in differentiating between if you create a regular collection or you create a time series collection. So once we specify these, the most important part is determining a time field. So a time field is basically asked to search through the data and specify a field which actually contains the timestamp of the data that you're getting. In our case, it's TS. And then we're able to convert it to make sure that it arrives at MongoDB in a format that is compatible with the MongoDB datetime specifications. Next, we thought it might be useful to you to sort of have some transforms, some SMTs, which will sort of enhance the way you experience your data. One of those enhancements that we proposed in our collection, and you'll see how that works out, is our rename field transform. Now, what that does is that we're getting data, we can't control what the manufacturers have done from the factory side, but then on our side, we're getting data that is mapped as H, P, T, and we have values attached to them. But to make sense of those values, we've created a rename field that allows us to then map those letters to actual stats that we're looking for, to actual data points that interest us. So when we look in our database, even though it's captured as H, it shows up in your database as humidity. If it's captured as P, it shows up in your database as pressure, and so forth. So you can do this for any number of data points that you're receiving in your Kafka topics, and it is mapped seamlessly to Atlas. Another transform we thought might interest you is the insert topic. So like I said, we're receiving droves of data. Sometimes you're mapping different topics to the same collection, for example, and we want to know sort of what part of the factory this information is coming from. One of the ways that we do this is using the insert topic transform, and we specify a field called station, which is then added to our database because it doesn't already exist. And that gives us the specific topic that we're mapping. So in our case, it takes the sensor surveillance camera as like the name of the station. So different stations will have different names, and they will also be streaming different data points from the factory. So we can talk and talk and talk about it, but let's just show you. Let's dig into the demo. This is the moment where we all cross our fingers and, call on all the deities that we believe in, but I'm rooting for us. I think we're in a good place. All right, so let's get started. I'm gonna refresh my Compass console so we can just see what to expect. So where I'm gonna be storing data in this database called Smart Factory. And I have some other, previous tests we've done, other stuff, but I'm gonna create a time series collection that is called webinar data. As you see, it doesn't already exist. So this is a previous test, let's forget about it. These are all the collections in my database. There is no webinar data. So I'm gonna come here, just make sure that my console is still awake. Let's send it a random message. Yeah, okay, wonderful, console is awake. Let's clear and let's get started. All right, so the first things you need to do, I'm going to use the exact configurations that we've seen in the previous slides. And I'm just going to deploy my connectors just as you've seen them. Remember that all of the source code that I'm sharing with you today is available on our GitHub repo. So we're gonna give you a link to that. So you can really just, copy, paste, reconfigure, and get something that really works for you. So also because I'm not a programming expert, I know we can get some commands to make this shorter, but we've deployed our source connector. There are no evident errors, so we should be doing fine. Next, we're gonna deploy our sink connector. Just copy that, put it in there. It says it received it. We should be doing all right. I always like to do one last status check so that, just to feel like I've done everything I'm supposed to do, and now we leave it to the machines to take over. We do a status check. So in all of this mess, anyways, what I generally tend to look out for is just to see this state running. This gives me hope, right? That as I've pressed enter, we're gonna start to receive data on the other end. So our factory is on, so it has stayed on. And I'm just going to go ahead and refresh my Compass. So Compass that I'm using here is a desktop client for Atlas. I thought it might be quite clumsy to have two browsers, so I'm using a desktop client. Now, as you can see, we've created a time series collection. We're just gonna open that. Oh, so the gods exist for anyone who was in doubt. Let's just have a quick look here. So we can see in our database, we're just gonna check out the time. Now, what you need to know is that my database collects data in GMT. It doesn't agree with, Central European Summer Time or none of that. So you see that all our timestamps are from 2 hours in the past. So wherever you are, this is GMT time. But this is right now what we're able to stream from the factory. So I expect that as I refresh and it continues to load different data points, they're all gonna show up in order. Now I wanna draw your attention to the transforms that we talked about. So now when I'm reading each document in my database, I'm able to see what every metric means. I'm mapping relative temperature, index air quality, regular temperature, because you need both, right? Air quality score, amongst a variety of other metrics. I'm also able to see my light dependent resistance. I used to know what that means. And also brightness. So if something changes, right, in real time, some of the metrics are set to stream every 1 minute or every 2 seconds. It all depends, but our database will start to fill up with that information. So now we have 8 records. As it continues to send, we add more records. So now we're gonna go into our source connector and see how easy it is to add one more kind of, one more topic. So let's just jump in there. I'm just gonna nano it. Let's not have the debate if it's going to be Vim or Nano. I've chosen Nano and I stand by it. So we're going to go into, this is the connector that I use. Actually, I think it might be nice for you to see that you can have several, if you look there, we have several connectors, source and sink. So you can really use as many as you need to get the job done. So we're nanoing again, because life is good. And we're just gonna get into our source connector. Let's try not to steal any details from here. It's okay, it'll all be changed after this session. But we want you to know that it is all as expected. We're gonna add one more topic. Now, this is a factory. So one of the basic things you expect to see is inventory. So I know that my inventory topic is called FI stock, and I'm just gonna put that in there and save this configuration. Yes, thank you. But now you've loaded a new connector, but you need to get rid of the old one because that's still running on the back end. So I'm gonna go ahead and delete the old source connector. Let me clear this so you have a better view. All right, I'm going to go ahead and delete my source connector. I should be able to run my status message just to see. Yeah, so we just have a sink and no source. This is still fine because Kafka acts as a hub to hold all of this data. So then let's clear it again. I think I'm clicking out. Okay, well, Control C. All right, so we have something new. Then I'm going to go ahead and reload the source connector because we've made changes so that the new changes are now what Kafka uses to stream. I load the new connector, all seems to be well. Let's run one more little status check so that there are no strange disappointments, right? So our sync connector, again, please feel free to optimize this so that it doesn't look quite as crowded as my console does, but I've gotten used to the mess. We have both connectors running, and if we come back into our database, we're just gonna give that a little refresh just to be sure everything is up to date. It's fetching documents. Oh, wow, so we're up to 26 documents now. So you see, we're getting data super fast. So I just wanna be able to show you really what the latest record is. So I'm just gonna sort this by timestamp. Over there, let's get it. Right, so this should show me the latest record. The latest record, 9:34, in my time, 11:34, that's perfect. And this, we now have stock records. So we have 9 spaces of inventory in our factory, and you can see all of those accounted for. So if there's a work piece in any one of that, we can check. So just like with a little extra, adding data points, everything is still captured seamlessly in your time series collection. How you can tell this time series, it says so right here. And you have this in real time. So we can add any number of topics, map them to the same Kafka topic, or any number of connectors to stream several Kafka topics, and it all really just works quite seamlessly. So we're gonna sort of look at the other part of this that we said, well, might be interesting for you guys. And that is the part about data visualization. So I'll hand you over to Felix so he can take it on from there. Remember, any questions you have, just feel free to leave them in the Q&A section, and we'll get to them after all the demos are done. Thanks. All right.
Perfect. Thank you very much, Joy. And I will take over screen sharing. I hope that goes smooth. That looks good. Everybody, can you see my screen?
Yes. Now we see your screen.
Okay, perfect. And I'm going to talk a little bit about MongoDB Charts, and some of you may have come across it already. MongoDB Charts is a fully managed, basically charts or BI as a service inside of MongoDB Atlas, and it uses the MongoDB query language. So if you're already familiar with MongoDB and the query language, you can directly query the data within MongoDB Atlas and visualize it in nice little charts. It's built for the document model. It uses the document model directly, no ETL, no data duplication required. It's very easy because it's basically fully managed and it's consumption-based pricing. And you can share the dashboards and dashlets with anyone. And I will also show you how you can actually embed that these dashboards, dashlets in any other web application. It's very powerful. It started with a bunch of relatively simple dashlets, a couple already years ago, and now it's really evolved into a pretty mature BI capability, giving you insights into all the different data sets, allowing you to combine data from different MongoDB clusters inside of MongoDB Atlas, including cold storage data, which we're going to talk about in the next webinar. And enough theory, let's have a look at it. I hope you can see my MongoDB Atlas UI. This is what it looks like. This is our data cluster, which Joy was connected to. And up here in the top right corner, you will see MongoDB Charts. You can literally just go there. If it's the first time, you likely have to activate it first, which will take a few minutes. And once it's enabled, you can then go and add your data sources in here, the different MongoDB clusters you want to access, and start creating a dashboard. I'll use a pre-configured dashboard and this little demo here. You see the different data sets, different chart types, all across our data sets, and it's quite easy to create a new chart. You just go here, you choose your data set. We can find that automatically created data source. We can then go add, let's decide on the chart we want to use. There's a whole bunch of different chart types: geospatial, text, circular. Most common one for time series data is likely a line chart. You can do a continuous one. You can then add the air pressure, for example, or maybe let's take humidity on the y-axis. We want the timestamp on the x-axis, and we can add other fields just as easy to these charts. We can then see this chart. We can further customize it. There's all sorts of configuration options. You can rename fields. You can smooth the lines. You can change colors, etc. You can add a title. Our little demo. Save and close the chart. It will be added to your dashboard. You can then adjust the size however you want it. And a thing which I really like, because sometimes you don't want to grant people access to a whole dashboard, but rather embed some of the data into other websites. And you can do that as easily. You just go here, go into embed chart. You can do the same for the whole dashboard as well. You can then enable access, choose iframe or the JavaScript SDK. And then if it's the iframe, you can literally just copy paste the iframe into any website where you want to see that data, combine it with other dashboards, dashlets you have created with other technologies potentially as well. So it's very easy, it's very straightforward. And we're going to go into more details, including the SQL connector in the next webinar. But just as a little teaser, how easy it is to actually get insights into the data within MongoDB. Some more colorful charts. And as promised, we have our Smart Factory GitHub repository. We'll do a few little documentation changes right after this. And feel free to use it. Look into the configurations, try to set it up yourself. It's a Docker environment. The config files will obviously be applicable to any Kafka setup using the same connectors which we showed to you. And I seen there's a whole bunch of questions, so we'll take time for the questions now. And you will get an email after the webinar, including the link to the recording. And also you will get a request and a poll if you want to reach out and talk to us directly for some specific topics. Don't hesitate to use that. We're happy to talk to you, help you get started with MongoDB and all the ecosystem around it. Perfect. So let's have a look at the questions. I see there's a lot of chat messages.
Yeah. Should we start from those in the Q&A section, perhaps?
Yeah, let's do that. I think that's a good idea.
Okay. So Vikas is asking, can we use MongoDB for DWH?
So I assume this means data warehouse. And MongoDB is definitely no data warehouse. So data warehouses are complementary. However, we do and will add columnar functionality. So that's kind of the differentiation between OLTP and OLAP, where the OLAP is basically the data warehouse part, which requires columnar indices or columnar storage. And we'll add that to MongoDB as well. So you can cover some of the aspects, some of these BI types of queries. But if you're really looking for a data warehouse, there's other tools which can do that better.
Right. We have questions about the compatibility with OPC UA to interface with this SCADA system.
Yeah, so there is an OPC UA connector as well for Kafka, if I'm not mistaken. So that's definitely something to look into. I'm pretty sure the Confluent team will happily talk to you about different capabilities. And then there's all sorts of other middleware which can be used to cover other protocols which may not be covered by some of the connectors. Right.
So essentially you want to set up your OPC UA connector as your source and your MongoDB Kafka Sink as your sink connector.
Correct.
Using a similar configuration.
Yeah, the power of Kafka is really to bring together multiple diverse sources, streamline them, and then bring them into a data store on top of which you want then build applications, etc.
Right. So Onyeka has asked, can we run analytics through a query database in Python using PyMongo? And can we visualize data in, that's essentially MATLAB, right? Matplotlib or Plotly.
So there's a Python driver, which you can happily use. There's even a Spark connector, which allows you to access the data and then run your Python notebooks. And then once you have the data in your code, you can literally do whatever you want with it, right? It's just a data frame or a dictionary, and then you dump it or you process it within your chart library of your preference.
Right. Nice. I hope that answers your question, Erika. Then I'm just going to group these together because they seem really similar. One person asked if we can use this for data insertion if the data comes from Kafka, and it's just basically going to be yes. So if you already have a source that you're getting data into your sort of Kafka hub, you just need to connect your MongoDB sink, and you have that data from Kafka inside your MongoDB collection. You just specify if you want it to be time series or not. And then another question says, can you update the document or only insert? So Kafka holds everything on one topic. So if the topic is updated, your database is updated. If you leave the topic the same, but you move it to a new collection, it basically just inserts everything that you have in that Kafka topic, unless you ask it not to. It's sort of like a from beginning clause that Kafka topics have. Then, right, there seems to be a problem in the Kafka connector that
I'll have to take that with the product manager. To get the details, feel free to reach out to me, felix@mongodb.com. And I'm happy to follow up on that one. I don't have the answer for that specific part.
We have another one. Julian asked, have you tried to use BSON inside of Kafka instead of JSON? Yes, so Kafka does have various converters. So there's a JSON converter, string converter, also a BSON converter. So at some point we thought that we wanted it to be BSON, but we finally went with JSON because it was most compatible with our source data as it came from the factory in MQTT. Then we have a question about if it's possible to use Confluent Kafka MongoDB Sink connectors. Oh, if it's different, what you have in the link, if it's different from our connectors. So just, yeah, I think, sorry, I would say, just go ahead. I can drop you a link to our connector.
That's the same. That's the same. It should be, I think it's the same. Yeah. So we have a partnership with Confluent, and in the Confluent Cloud, etc., they're actually hosting our Kafka source and sink connector. So it should be. I'll check the link, but I'm pretty sure this is actually the same.
Nice. But if you get it from our website, it's fully documented and you get extra tutorials on everything. So that's always nice. Then how can we trigger events going out from MongoDB Atlas if the temperature goes over a certain threshold? This is why you need to come back in September, because we're building alerts management into this process to see how we can flag certain values that are above or below. And I think we'll go into it in more detail in part 2 of this webinar, which comes up September 26th. You'll get details to that shortly.
Yeah, just briefly, you can leverage change streams, which is basically database triggers inside of MongoDB to check for inserted records or updated records, and then compare that to a certain value, and push a message back onto Kafka, or if you're using AWS, onto EventBridge directly inside of MongoDB, or literally to anywhere, because it's your code. So change stream watches the uplog, reacts on changes, and then allows you to process that information however you would like to do so.
Right. We have something fun. Felix, do you have any thoughts on geospatial queries and using time series collections for those? Is there a specific benefit, or does it work similarly?
This is actually an interesting topic, and I do think we added geospatial indexing, or we're going to add it soon on top of the time series data. And I can think of a bunch of scenarios where it may be interesting to see kind of how sensors behave in a certain geographical area, for example. Maybe for fault detection, or maybe to identify certain patterns. So I do think there's definitely benefits for that. Or if you're tracking items and you want to see which items are actually nearby, and leverage the benefits of a time series collection for storage and query optimization. Yeah, definitely. There's use cases which will benefit of that functionality. I'd have to check if that's already in the product with version 6.0 or if it's coming up.
Right. Another one that I think is really fun, we might all profit from this, is can we migrate to Kafka and time series if you already have like a regular MongoDB collection that you use a different model?
Yeah, it's basically, you would have to do an ETL job. You can use the MongoDB aggregation framework to do so, transform that data and dump it into another or a time series collection, or loop it through another ETL tool, or the Kafka connectors can actually do the same. Pipe it through a Kafka stream and then bring it back into another database or MongoDB, another MongoDB collection.
Right. So for that purpose, I've sent you a link in your question, just in the Q&A section, and it links to an excellent tutorial. I should probably also put it for everyone. If you already have a regular collection in MongoDB, but you want to start to use time series collections, this tutorial basically shows you how to set up your Kafka and then start to basically stream from a collection to another collection, but from regular to time series. So yeah. Is there any plan to correctly support sharded clusters on the MongoDB source connector? Right now we have a throughput decrease where, sorry, I'm not reading this correctly, whenever there's more than 50 operations per second. I think this has to do with the first question.
Well, yeah, there's optimizations in process, work in progress, or already completed with 6.0 to make that more efficient and better. I'd have to check back with the product team to figure out if that's been solved and optimized already.
Right.
Feel free to reach out again, send me an email, and I'm happy to look into our Jira tickets to see what the current progress is on that one.
Nice. For questions on cluster to cluster sync, unfortunately, we're not going to be tackling that in this session. We just go with questions that have to do with the webinar. But feel free to just contact industry.solutions@mongodb.com or use the email that you will get the contact details that you will get in the email after this to contact us with questions that are not related to the webinar. And then,
this is actually, yeah, we're going to do another webinar, but definitely possible. That's another feasible scenario where you copy one MongoDB cluster into another. The first version of cluster sync will actually, you will have to duplicate the whole MongoDB cluster. And we'll, in the next release, we will add collection filters, which will then allow you to literally choose a distinct collection and just synchronize that collection into from a self-managed MongoDB cluster into MongoDB Atlas, or the other way around.
all right.
And then we do have another question around performance benchmarks. I do not have the latest insights after the 6.0 optimizations, because we've spent quite a bunch of time on optimizing all sorts of operations in that. I would have to check that.
Right. So while we don't have actual figures, I've been deleting a lot of time series collections just preparing for this day, and it is as fast as inserts. So I don't know, we'll see if we can get some figures for that, but I think you'll be just fine.
Good. I hope we haven't overlooked any of the questions.
Yeah, we're gonna go through again, because some have come through the chat, some have come through Q&A, but yeah, if there's anything else, we're kind of running out of time, so we want to close things out.
Yep, thanks everyone for participating, joining, or watching the recording afterwards. I'm looking forward to see most or all of you, or even more people in the future webinars again. And if you have suggestions, ideas, etc., feel free to add that. We're happy to create a lot more content around these different topics, IoT, industrial IoT, etc. Thanks very much. Have a good day. Bye-bye.